All right, this is the second part of the Unit 3 review. So we're starting here on number 5, calculating wavelength and frequency. Well, I guess the first thing we need to know is the formula. C equals lambda nu. So c is the speed of light. Lambda is this guy. This is wavelength in meters. And this is nu, which is frequency, which is measured in hertz or cycles per second. Okay, and so the only other thing you need to be aware of is that this thing, c is the speed of light, and it's a constant, 3 times 10 to the 8th meters per second. So I would put that on my note card. Okay, so then all I do is I plug into this formula what I know, rearrange and solve for what I don't know. Okay, so I know 3 times 10 to the 8th meters per second. I know the wavelength. Okay, so that's going to be 6.8 times 10 to the negative 7th meters. And my frequency is what I don't know. That is my x. How do I solve for x? I'm going to divide 6.8 times 10 to the negative 7th meters. Meters go away. I'm left with per second, which is hertz. I grab my calculator. I enter 3 EE8 divided by 6.8 EE negative 7. And I hit enter. And this is the answer it gives me, 4.4 times 10 to the 14th per second, or hertz. That is the unit. Okay, the next one, number 6, same thing, same formula, c equals lambda nu. Okay, and so speed of light still is 3 times 10 to the 8th meters per second. This time I don't know the wavelength, that's fine. Frequency I do know, 2 times 10 to the 9th hertz, which is per second. To solve for x, I'm going to get it by itself. 2 times 10 to the 9th per second. This goes away. The per second goes away. I'm left with meters, which is fantastic. So I'm ready to solve. I'm going to enter 3 EE8 divided by 2 EE9. And when I do that, I'm going to get 0.15. The unit is meters. So that is your answer for part 6. Okay, next one. We're looking at the 4 set of quantum numbers for the element scandium. That's probably where I came up with scandium in the first problems. I was thinking ahead and I wasn't looking at what I was doing. So that happens. So make sure you're reading carefully. At least I caught it before it was too late. Granted, I had spoken for 12 minutes, but whatever. It is what it is. All right, let's look at the quantum numbers. So I'm going to give you a hint. When you're doing quantum numbers, what you're looking for is literally, you have to draw the last part of the orbital filling diagram. So you guys notice that scandium is going to end with 3d1. And so I need to draw the 3d1. So here is 1, 2, 3, 4, 5 orbitals. Here's 3d, and this is 3d1. Okay, now the quantum numbers, there's a set of 4 quantum numbers. There's n, l, ml, and ms. And so these stand for, n is the principal quantum number, L is the angular momentum quantum number, ML is the magnetic quantum number, and MS is the spin quantum number. So what do these things mean? N is the energy level. And so it's just telling me what ring it's in, what orbital, or which energy level. This one happens to be in the 3rd energy level. So the first quantum number is 3. L, which is the angular momentum quantum number, that's telling me, this is telling me the shape, the sublevel shape. And remember, they're each assigned. So S is 0, P is 1, D is 2, and F is 3. And so notice this is traveling in 3D, D is 2. So 3, 2 are the first number, or the first 2 numbers. ML, which is the magnetic quantum number, it's telling me what orbital it's in, and so remember, it's just like a number line. This is 1, or excuse me, this is 0, this is 1, this is 2, this is -1, this is -2, so it gets more positive as you go to the right, more negative as you go to the left. So what line does that electron live on? Well, it lives on the -2 line. And then finally, it wants to know which direction. And so this is, we said line, and so this would be like -3, -2, -1, 0, 1, 2, 3, right? Just like number line when you're in elementary. The spin of quantum number tells me which way the electron is spinning. If it's spinning up, it's +1/2. If it is spinning, oops, what am I doing here? Time for me to go home. Spinning down is negative 1/2. So it's just telling me the orientation. Notice it's spinning up, positive 1/2. So those are the 4 quantum numbers for scandium. Okay, 3, 2, negative 2, positive 1/2. Okay, next. This page is just the definitions. Okay, so these are just the vocabulary terms that are on it. All these terms are found, there in your note packet. So if you're looking at it, you can see it. Notice these aren't in order. So like usually when you do the quantum numbers down here, they go N, then L, then ML, then MS. So don't be confused by that. But these are the definitions. You can go ahead and just take a moment and pause the video and check them. I'm not going to sit here and read these to you. You can read. Okay, hopefully they're big enough you can see. Otherwise, look in your notes or Google it, right? But those are the definitions of those vocab terms from the Unit 3 exam. Okay, so hopefully you paused it. I'm going to move on. And here we go. The last part are mole conversions. Okay, and so I'm going to strongly encourage you to model just like I do when I'm doing mole calculations. So looking at this problem, I know moles and I'm going to molecules. Moles and molecules are related by Avogadro's number. Okay, so I'm going to start out what I know. What do I know? I know I have 5 moles of sodium chloride. Well, if I want the moles to go away, the moles need to be on the opposite side. They need to be on the bottom. And the nice thing is that when we're doing moles, it's always 1 mole. 1 mole of sodium chloride. Well, how many molecules is that? It is Avogadro's number, 6.02 times 10 to the 23rd molecules of sodium chloride. Moles cancel. I'm ready to solve. And so if I multiply 5 times 6.02 EE23, my calculator is going to tell me 3.0 times 10 to the 24th molecules of sodium chloride. That is your answer with sig figs. Technically, it should be formula units, but whatever, it's molecules. For B, wants to know how many grams are in 3.5 times 10 to the 23rd atoms. Okay, and so in looking at this, I have atoms and I'm going to mass. Okay, there is no direct relationship between the number of particles and the mass of an element or a compound. Okay, the thing is if, notice this problem does not mention the word moles at all. It has to mention moles because moles is the thing that relates atoms. So atoms and moles are related. Grams and moles are related. Atoms and grams are not. So we need to go through that intermediate step. This is going to be a 2-step problem. So when I do this, I'm going to start with what I'm given. 3.5 times 10 to the 23rd atoms of hydrogen. Okay, and I want to convert these things into moles. So how do I do that? Well, I know that every 1 mole of hydrogen is how many atoms? 6.02 times 10 to the 23rd. And this is atoms of hydrogen. Atoms cancel. I now know moles. Notice that number is so large. That's 6 times 10 to the 23rd. It never goes with grams. It never goes with moles. That word is only associated with things like particles, atoms, molecules, formula units. Anything else is way too big. So that number only goes with those terms. Okay, now I know moles, but I didn't want moles, I wanted grams. So I need to do the molar mass of hydrogen. How do I find that? I look it up in the periodic table. According to the periodic table, for every mole of hydrogen, it's going to weigh 1.01 grams of hydrogen. Moles cancel. I'm left with grams, which is great. That's what I want. I'm going to solve. I'm going to multiply the numerators, divide by the denominators. So I take 3.5 EE23 times 1.01 divided by 6.02 times 10 to the 23rd. When I do that, I get this, 0.59, and the unit is grams of hydrogen. Last problem. How many moles are there in 23 grams of potassium iodide? Okay, so we're going to start with what we know, 23 grams of potassium iodide. Well, because I'm doing moles and mass, that's just molar mass. So I need to find the molar mass of potassium iodide. I'm looking at my periodic table. Potassium weighs 39.10. Iodine weighs 126.90. And so if I sum these together, I get 166 grams per mole. That is the molar mass of potassium iodide. To get rid of the grams need to go on bottom. How many? 166 grams of potassium iodide. And that equals how many moles? 1 mole. And so grams cancel grams. I'm ready to solve 23 divided by 166. My answer, 0.14 moles of Ki. Well, that was the last problem. Hopefully you found that useful, and hopefully you can answer these questions correctly, and you'll be prepared then for the Unit 3 exam.